All right. So the goal here is to just kind of physically identify what makes up the Victron system that QTC has in these 4 Nomads. We've gone through the electrical diagrams, and so Leslie and the crowd have kind of the logical electrical diagrams. I just wanted to physically point out what some of this equipment was, so they can get it straight in their mind. So we talked about the 2 inverters. So these 2 bigger boxes, these are the inverters. There's one for leg 1, there's one for leg 2, so that you've got 120 volts and 240 volts between them. These are the DC bus bars. Basically, this is where all the 48 volt stuff, the energy flows. So, the one over here called Links Power In. On bus number 1, it is a Links distributor with fuses in it. But the batteries come in on the left. The chargers, the inverters and whatnot are connected on the right. And in the middle is the battery management system, the BMS that we've talked about. And inside of here is a contactor. And a contactor is basically just a big heavy duty relay, or a switch, if you like. So if the batteries get to a certain level of discharge, say they're getting near empty, once they get to a certain point, in order to keep the system from completely draining, this contactor is going to open. And it means that the inverters won't work anymore. The solar charger is going to be disconnected from the batteries and all that. So there's going to be a little bit of room left in the batteries, even when this thing says it's 0. And I designed it that way on purpose so that they would never hopefully go totally flat. But periodically, the buses have been left kind of alone, not plugged in or whatever, and the batteries have gone empty. And what that means is this opens up. And so I've asked QTC on a couple of occasions to reset the system. And what that means is there's a little button over here on the left side. It's a silver button on buses 2, 3, and 4. On bus 1, there's a rotary switch up in the middle compartment. But in normal operation, this button is pushed in, and that means that this contactor is closed and everything works. If I were to push this button, which I won't right now, basically it's just a switch that tells this thing to open up. These are the 4 battery modules. These 2 are in the bottom are in a pair. These 2 on the top are in a pair. They're 24 volts each. This one's in series to make 48 volt battery number 1, 48 volt battery number 2. There are heating pads under each battery that is thermostatically controlled with the thermostat that's attached to one of the bottom batteries. It's kind of just set and forget. It happens automatically. If the thermostat down here gets below about 50 degrees, it will kick on and start warming the batteries. That way, if the vents are left open in the winter time, hopefully we don't have a situation where the batteries get so cold that they tell the BMS that they won't charge. So when the batteries get really low, if they get very cold, or if they get very hot, those are things that can basically cause this BMS to open up the contactor and say, hey, you need to figure out what's going on. This is the solar charge controller up here. It says Smart Solar Charge Controller. This is the servo. This is what drives the touchscreen up here. It's what also gives us remote connectivity so that we can see what's going on here in the electrical system of the bus. So it's got an Ethernet plug that's connected to QTC's Aruba network gear up in here, and that provides an Ethernet connection and then ultimately gives us visibility into the Victron remote management portal. There's a red switch for each inverter. Basically, it is a battery disconnect switch. So the DC power that comes from the batteries go into this switch to feed the inverter. That's here more for maintenance purposes, not operational use. If we needed to work on something or replace, say, an inverter failed and we needed to replace it, we could close that switch, isolate it, and safely work on it. Let's see. Over here, I've already mentioned that this is the main system switch, and below it is a set of circuit breakers, and on this bus it's labeled hydronic, and those are the electric heating elements in the hydronic system. And we really only should be using them if for some reason the diesel furnace back there has failed. This is a redundant means to provide hot water for the sinks and for heating. I would think that it would be best to run the generator. I think you ought to start the generator if you think you need to turn these on, because they will consume a lot of power and drain the batteries fairly quickly. So by default, I would leave them off. Over here, out of the picture, but there are two big fuses. They're the main battery fuses. There's one for each battery, and it's a fuse block about like that. On this side over here, we have another set of circuit breakers. We have some for the DC powered air conditioners, which right now we aren't using. And we have another one labeled solar, and that's just a disconnect so that, again, if we need to perform maintenance and we don't want all that power coming in from the roof, we just basically use that as a switch. So the main components of the system are basically the inverters, which operate as a single inverter. We've got the DC bus bar system, where the batteries come in one side, all the loads and chargers are on the other. The BMS is in the middle. The BMS monitors the state of the batteries, and if necessary, will disconnect the batteries from the rest of the system. The servo, the smart solar charge controller. This is the Victron system, and we can see what's going on the touchscreen.